Hi friends, welcome back. This is Santosh Kumar. So till now what we have seen all properties of root locus. Okay. Last time we considered one problem only. You people may have some doubts in that, but today I'll clear all your doubts. Everything will be clear out. How to apply all those whatever we have seen the rules for the root locus. Today I'll take one problem, everything will be out. Okay. So today's session is the root locus problems session. Okay. So whatever rules we have seen, we'll understand with the formula and all by the reverse approach. This is my approach, and this approach is I have already drawn one root locus diagram for a particular question. Here I'll show you what are the points we have to calculate it over here. Okay. So it will be crystal clear to you people that these are the formulas we have to apply and these are the points we can calculate before drawing the diagram. Okay. So this is the reverse of approach. I have the RL diagram. I'll go to the, or I'll show you what are the parameters I have calculated over here. Wait a minute. So if this is the diagram, what will be the open loop transfer function? Yes, we can get, see, the first pole, this is the pole. Okay, the poles is denoted by this cross sign, and if you have 0 it will be denoted by round circle. So the first pole you are getting at S. Let me change the color. The second two poles you are getting at -1, so it's kind of S plus 1 square, and the third one you are getting at -2, so definitely it is S plus 2, isn't it? So this is your transfer function. So corresponding to this open loop transfer function, remember always it's open loop transfer function. Corresponding to this, I have drawn the root locus diagram. The root locus, the characteristic equation of this system, and the roots of that characteristic equation will follow this graph, isn't it? So let's come over here. The first of all, we'll check how many poles we have. So number of poles we have mentioned on the real axis. The number of poles, if I'll talk about number of poles, so there are 4s, 1, 2, 3, 4, 5, 4. Number of zeros, if any? No, I don't have any number of zeros. Okay. Then see this is the starting. I'm telling you how to start. If this one is given, you will start the root locus. Drawing the root locus, how you will start? First you'll find out the number of poles on the real axis and zeros whatever given in the system. Then you will find the RL branches. What is the procedure to find out the RL branches or the root loci? One by one you will go to the each and every point, and you will see to the RHS of that point. If the number of poles and zeros to the RHS of the particular point are odd, then only the RL will exist between them. Okay. Over here, I'm over here. Wait a minute. I'm over here. I'm looking to the RHS. Nothing I'm getting. So there is a no RL branch over here. So this part is over. Then I came over here. At this point, when I look to the RHS, I'm getting one pole. So 1 is the odd number. So between these two, I have one RL branches. I have drawn over here by this color. Okay, this color denoted the root locus. Okay, everywhere. Okay, so I have drawn this RL between these two. Perfectly fine. The next point is this. When I'm coming to at this point and looking towards the RHS, I'm getting 3 poles, 1, 2 and 3. So total 3. Again between these two successive poles arrangement, I'm getting RL branch. So definitely you have this RL branch. Okay. Now the question is, RL branch is okay, everything is okay. Now we are getting these 4 lines, 1, 2, 3, 4. What are these lines? These are the asymptotes. Why asymptotes? Because along with the asymptotes, your RL branches will go to the infinity. Now the question is, why these branches are going to infinity? Why? Because the starting points are poles, and poles will start at k equal to 0 and will go always to the infinity to meet their respective zeros, isn't it? So this pole will start its journey. Let me draw over here. Wait a minute. Let me take the pen first. This pole, one of these poles will go to here. Two poles we have. So one will go to this side, one will go to this side. So one of the poles are going to this side. Okay. Simultaneously, this pole is also coming. So they are contributing over here the breakpoint. So the breakpoint also will be calculated for this, isn't it? So here I'll write for you the breakpoint. How to calculate breakpoint? We will frame the equation in the form of k. It's kind of like this. Now you will find dk by ds. We'll equate that equation to 0. So you will get s1, s2, whatever. These are the breakpoints. So you will choose the valid breakpoint. How you will choose the valid breakpoint? If your breakpoint is available on the RL branch, then it's valid. Otherwise, it's not valid. Okay. So BP is over, breakpoint is over. So definitely you'll get breakpoint over here also, because one of the poles from this side will go like this, and this is coming from this side. They are meeting over here, they are breaking themselves over here. So breakpoints, again you will get the breakpoints. Okay, so definitely by this equation you will get both the breakpoints. Okay, now after reaching to this point, one pole will go to this side. Okay, the direction is always from pole to 0, always. So the zeros for this particular pole is waiting at infinity. Here it's zeros, and you know very well I don't have any zero in the system. So all zeros means the zeros equal to the poles, because this is the must condition for root locus. P should be equal to Z. P are 4 over here, so definitely we'll be having 4 zeros but at infinities. So 1 0 will be over here. Let's take it Z1. 1 will be over here. This is Z2. This is Z3 I'm taking, and this is Z4. All are at infinity. I think you will be understanding this. Okay, I had drawn like this. So over here, two poles are meeting. One will go to this side. Okay, and it will reach to the infinity. The same thing will be happen over here also. So what are the points we have calculated? The breakpoint we will calculate. The RL branch we will directly, we can just directly. Okay, then okay, this is the point. But before that, let me come over here. This is the centroid or not? The point where the asymptotes going to intersect the real axis is called the centroid, and the centroid formula is given by del p minus del z divided by p minus z, where this p minus z is the number of poles and zero. So this is the formula over here. So we need to calculate centroid always in each and every root locus. This will be must to calculate. Okay, so centroid will be okay. Now we have angles also. This is theta 1, theta 2, theta 3 and theta 4. So I have to calculate these angles also. So angle of asymptote formula, if you remember, 2q plus 1 into 180 degree divide by number of poles minus zeros. So this is the formula. Where what is the q, you know very well, 0, 1, 2, and for this it will go to 3, because 4 poles you have. 4 minus 0 minus 1, that is 3. Okay, so angles are there, centroid is okay, breakpoints are weak. Wait a minute, let me take care of breakpoints we calculated. Here centroid is over, angles are over. Now one more thing will remain over here. See, this root locus diagram is going to intersect to the imaginary axis also, and this thing also I can calculate. How to calculate this? I'll make the characteristic equation. Okay, 1 plus gs hs. I'll frame this. Then I'll find out the RH table. In the RH table, I'll find K marginal, and then I'll find A's, okay, in the form of plus minus AI, isn't it? So is there anything remain? No, I think it's enough. Now when I'll take the problem, we'll take this one, I mean we'll be having only open loop transfer function, then we'll calculate this each and everything, we'll draw the root locus. So friends, let's start the day. So this is the question given, open loop transfer function k divided by s square plus 2s plus 2 and s plus 4 is also given. Now let's find out the number of poles. Yes, definitely you have 4 poles. The first one is at 0, the one pole is at -4, and over here you have to calculate this s square 2s plus 2 equal to 0. When you will find out, you will get s equal to -1 plus minus j. So total number of poles you have are 4. Okay, let me directly write over here now. The third pole you will be having, and that is equal to -1 plus j, okay, and s equal to -1 minus j. Okay, so these are the 4 poles you have. Now can you mention all these poles in the S-plane? Yes, we can do. The first one is at s equal to 0. The second one is over here, I'll draw because these are related to the real axis, so -4. Okay, I'm sorry, over here this is, let's take -1 plus j, okay, and conjugate of this is -1 minus j. So these are the 4 poles. Okay friends, now so first thing is over number of poles you located on the S-plane. The second one is how many number of poles and zeros you have. The poles you have 4, number of zeros you have 0. Okay, perfectly fine. The third one is find out the RL branches. Find out the RL branches. See, wait a minute. For the RL branch, I'll take this color. First, I'll come to this point. Into the RHS of this, nothing I'm getting, so no RL branch. Then I'm coming over here. How many? Only 1. And this 2, if you want to consider the complex one, yes, you can consider, no problem at all. So number of this we are getting 3. So over here I'll have 1 RL branch. This complex pair always will be in even, means 2 or 4, 6. If you are finding over here only 1 or odd number and you will add that this pairs number, so definitely we are getting odd number only, so it's not matter. So what my point is, suppose at this point you are looking to RHS, you are getting 1 only, so you have to consider 1 only, then also odd. If you will add this 2 poles, then 1 plus 2 is 3, this one is again odd, so RL branch or the identification of the RL branch will be not affected because of this conjugates. Okay, now RL branch you have find out, no problem at all. Now the thing is, you have to find out the asymptotes you can find out. Definitely we require the asymptotes. So how many asymptotes you have first? The formula is n equal to p minus z. Here p you have 4 and zeros are 0. So total 4 asymptotes you have. Okay, asymptotes are clear. Now the intersection of the asymptote to the real axis you can calculate, that is sigma, and the formula of the sigma is summation of p, these are the real, okay, minus summation of z, these are also real, divide by number of p minus z. Okay, so number of poles, first 0, -4, -1, -1. Okay, did you get it? See, The first pole 0, second one is -4, third one is -1, fourth one is -1. Over here I'll consider only the real parts, not the imaginary parts. Okay, minus summation of zeros. I don't have any zeros, so definitely it will be 0. Divide by number of poles, that is 4, minus number of zeros, that is 0. So finally you are getting -6 divided by 4, that is -3 by 2. So your centroid point where it will be, your centroid point will be at -3 by 2. Okay, so it will be, let's take it, this is 1 and some up over here. This is your -3 by 2, isn't it? So this is your centroid point. From this centroid point you will be having 4 asymptotes. This is the centroid points, and from this point you have 4 asymptotes. Now you need 2 angles also, so you can easily draw your asymptotes. The formula is 2q plus 1 into 180 degree divide by p minus z, that is 4. Okay, so the first one is 180 divided by 4, so it is 45 degree. Okay, this is the first one. Let's take it 5 1. Then you will calculate 5 2, then 5 3, and then 5 4. 5 2 will be 135 degree, 5 3 will be 225, and 5 4 will be 315. You can easily calculate this one. So the first asymptote will go from centroid by making angle 45. Wait. So the first asymptote will make the 45 degree angle from the real axis and will go from the centroid, that is -3 by 2. So let me draw the asymptote over here making 45 degree angle. So definitely they will be symmetric. So they will be like this. One is at 45, one is at 135. So these are the asymptotes. Now the scene is, 2 poles you have over here, 2 poles you have over here, and all poles will go to the infinity. So these 2 poles, suppose let's take the condition is like these 2 poles will go, suppose in this way and in this way to infinity. So this 2 asymptote will carry to these 2 poles. It means, see, the condition is, or it may be like this, these 2 poles will go to this side, they will go to this side. So it will depend on the angle of departure, isn't it? So I have to calculate phi d over here. Okay, no problem at all. So 2 poles, whenever you have 2 conjugate poles and in between them if you have RL branch, so definitely there will be one breakpoint. So there will be one breakpoint on the real axis. It will be over here, the breakpoint. These 2 poles will go like this. Wait, if breakpoint is over here, so from the breakpoint 2 poles will go to the infinity along with this 2 asymptotes. Okay, so we have to calculate the breakpoint also. So 2 things we have to calculate to proceed further. The one is phi d, that is the angle of departure. Why I am calculating angle of departure? Angle of departure always calculated for the complex poles. Okay, and the second thing I had to calculate is the breakpoint. Okay, so what is the formula? Wait a minute. The formula for first I'll find out the breakpoint. So breakpoint approach is you have to form the characteristic equation. So 1 plus GSHS, that is given as s plus 4s square plus 2s plus 2 is given, okay, equal to 0. So you have to form the equation in the form of, means you will keep k over here and everything will be go that side. So it will be kind of, I'll multiply over here s square plus 4s s square plus 2s plus 2 plus k equal to 0. Okay, this k you will take this side, everything will be this side. A square plus 4s, a square plus 2s plus 2 equal to minus k. Now you have to differentiate it. So dk by ds. So d by ds. Now differentiation you can do easily. So when you will differentiate this equation, what you will get is 4s cube plus 18s square plus 20s plus 8 equal to 0. Okay. So let me clear one point over here. In the GATE examination, they are not asking like this, that you have to draw the root locus. When we'll come to the GATE problems, I'll tell you in the GATE examination how the question will be framed from the root locus. Okay. So this is the generalized approach. That's why we are going to understand this. Okay, friends. So when you will calculate this, the poles will be minus 3.09 and minus 0.70 plus 0.388j minus 0.70 minus 0.388j. So these two are invalid. Why? Because they are not on the RL branch. RL branch is over here only. So you have only one, that is 3.9. So somehow over here it's a breakpoint. It's 3.09. What it means? Means this pole will come like this, like this, like this, like this. At this point this will come like this. They will break over here and will go. One will go to this side and one will go to this side. Okay. So this is over. Now we have remained with the two poles, complex pole. One is over here, one is over here. So definitely they'll contribute the angle which is like this. So we'll calculate that, don't worry. But this is sure that this two branches will go like this. Now you have to calculate only the angle of departure, at what angle they will depart. But definitely you will get the root locus like this. Now the question is how to calculate the phi d. Okay, so let's come to calculation of the phi d. Over here I'll calculate phi d and the formula is 180 minus phi, where this phi is summation of phi p minus summation of phi z. Okay, so now I'll tell you two approaches. One is graphical, one is analytical. In the last question I told you the graphical method. Now I'll show you the analytical method. So in the analytical method, wait a minute, I'll use the formula phi d equal to 180 plus this phi, where this phi I can directly calculate. This phi, this is nothing but whatever the transfer function is given, g of s, h of s, the angle of that particular at the given point, means at s equal to whatever you are looking for. For this question we are looking at, let's come over here, minus 1 plus j. So at s equal to minus 1 plus j, you will calculate the angle contribution of that pole. Okay, now that you will add over here, this is the formula for phi d. Okay, so what is my GSHS for this question? That is, wait a minute, over here it's given k s plus 4, this is nothing but s plus 1 plus j, s plus 1 minus j, isn't it? Now let's find out the angle of this. So, angle of g of s, h of s. So angle provided by the numerator is 0. This is pi by 2 because tan inverse infinity. What about this? This all are in multiplication, so you can add them. This will be tan inverse. Wait a minute. Put the value of S, so it will be very easy to calculate. Wait a minute. What I'm saying is just put the value. Which value? The value over which you have to calculate the, wait a minute, calculate the angle. Okay, so first I'll reduce this. The S is nothing but minus 1 plus J. This part is over. Minus 1 plus J plus 4 is also given. Minus 1 plus J plus J, and it's minus 1 plus J plus 1 minus J. Okay, so finally you have K divided by minus 1 plus J. This part is over. This is 3 plus J. Okay, and this one is minus 1 plus 2J, and the last one is 0. Okay, now calculate the angles. So I'll write this over here on the next. This is our G of S, H of S, open loop transfer function. So we put the values, and finally we are getting minus 1 plus J, 3 plus J, 1 is 0, and 1 is minus 1 plus 2J. Okay, now calculate the angle. G of S, H of S equal to, it's 0 angle provided in the numerator. In the denominator it will be tan inverse 1 by minus 1 plus, why plus? Because angle will be added if the terms are in multiplication. So the second one is tan inverse 1 by 3. You know very well how to calculate A plus JB. Contribute the angle tan inverse B by A. B is the imaginary part and A is the real part. The third one is, this is 0, so it will be 0. And the next one is plus tan inverse 2 by minus 1. So this is 0, tan inverse minus 1, 135, don't write it minus 45, minus 45 is wrong. Okay, tan inverse 1 by 3, it will be 18.4300, and you will get 90. I forgot plus 1 over here, it will cancel out. So finally you will remain with 2J only. Over here 2J, so that's why this 2J is contributing 90. And finally the angle you will have is, you know, minus 63.45. okay, I'm sorry, wait a minute. The angle will be, add all this, final angle 0 minus this, they are in division, so we can subtract them. Okay, so 135 plus 90 and plus 18.43, this 43 will be as it is. Calculate this, 13, 1, 14 and 2. Okay, so this is your angle phi. Which angle? And this is in denominator, and the final angle is 0 minus 243.43. So finally you are getting minus 243.43. Okay, so in this formula you have to put the value to calculate the phi d. So your phi d is 180 minus 243.43. So you are getting minus 63.43. This is your angle of departure. So this is the complicated analytical method. So that's why I always prefer the graphical method. The same thing we'll do by the graphical method also. Let's come over here. Now you got the angle that is minus 63.43. So this will depart by the angle minus 63.43 and will go to the infinity. So this is the overall diagram of the root locus for the particular system. So this is the approach. But don't worry, in the GATE examination they are not asking the question like this. They'll not give you any transfer function, they'll not ask any diagram. Okay, the diagram will be simple. As you know very well, the root locus, you know, it will take 10 to 15 minutes to draw. So this is for the semester exam only. For the GATE exam, in the next class we'll discuss the GATE problems. There I'll tell you the funda, tricks and everything. Okay, and for the calculation of this phi d and phi a, do practice. So if you'll do practice, your doubts will be clear out. Simply I'm saying you the phi d, if you want to calculate by analytical method, you will use the formula 180 degree plus phi, where this phi is nothing but the angle of your given transfer function, that is GSHS. This is nothing but your phi. Okay, and where the particular point, okay, where the point where you want to calculate the angle of departure. Okay, in this way you can calculate this. Then wait, and okay, and suppose you want to calculate by the graphical method, I'll use the formula phi d 180 degree minus phi, where this phi is nothing but the angle provided by the poles minus angle provided by the zeros. Okay, so friends, this is all about the today's class. In the next lecture, when we'll start the GATE problems, I'll tell you how the question will be framed by this unit. Okay, and if you have any problem with this angle of departure and angle of arrival calculation, we will sort out in the next lecture. Okay, we'll meet in the next. Till then, take care and bye.